Alright, so by the end of the day, you'll be good at using sine, cosine, and tangent in order to find various angles or lengths of different parts of a right triangle. That's our goal. Use these to find stuff about that. So let's start with the first part. This is a right triangle, and we have different labels for the different parts. First thing, the round thing means our angle, and this symbol we call theta. So theta just means this angle here, like theta equals 20 degrees. On a circle, that's 20 degrees of the whole circle. This means it's a right triangle, so this means 90 degrees. Okay, first parts. The long kind of connector piece, the piece that we were looking for when we were solving for displacement, is called the hypotenuse, or HYP. This is theta. The side touching theta is the adjacent. That's what adjacent means, to be touching. Like California is adjacent to Nevada. And here's theta, so over here is the opposite, or OPP. So now you try a couple. So I'll just draw some random triangles. So for each of these, label them opposite, adjacent, or hypotenuse. Here's the answers. We have theta, so this is opposite. Hypotenuse is the easy one. And then theta, here's the opposite. Theta, here's the opposite. That means this one's the adjacent. And this one's the adjacent. Okay. Sine, cosine, and tangent. And these are things that we can use to find the angle of any part. And there's formulas that go with each of these. So the thing to remember is, I heard this in like 7th grade, that there were these great math Indian tribe in the Napa Valley, the Sokotoa tribe. Sokotoa. Sine, Sokotoa, sine theta equals opposite over the hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. So these are the formulas that we'll be using to find angles or sides. So you can either use this to find theta, which is the angle, or different parts, the hypotenuse, the adjacent, and so on. So the idea is, given an angle, can you solve for the hypotenuse? Or so given an angle and a hypotenuse, solve for the... Alright, so here's problem number 1. Let's find the opposite. Now I know the hypotenuse, and I know theta, and I need to find the opposite. So now I go over here, and which one of these, if I know the hypotenuse and the theta, can I find the opposite? So I'm going to use sine. Sokotoa. So my formula is sine theta equals opposite over hypotenuse. Or sine 30 equals opposite over 12. And then to solve for the opposite, you do times 12, pull up the calculator, and this is where it gets different. Some calculators, you put in Sine, you push sine and then hit 30. Sum, it's the other way around. So this one you do 30, press the sine button, equals sine 30 is 1.5 times 1, 2 equals 6. So I know the answer right here is 6 meters. Okay, now you try doing the cosine. Pause the video. Here's the answer. Cosine. So this will tell us the adjacent. We'll do a different color now. Cosine 30 equals adjacent over 12 times 12 times 12. 30 cosine times 1, 2 equals 10.5, 10.3. Oops. Okay, here's another one. I want you to do both sides all on your own. Okay, here's your questions. These are the angle, theta. These are the hypotenuses that are known. You solve for the other two missing sides. Finish them all, and then the answers are about to pop up. I'll do one at a time. So here's the first one. And 30 sine 15, so you divide over, equals 7.5. On the next one, for right here, that's the adjacent, so we need to use this one. Cosine 15 equals adjacent over 30 times 30 times 30. Answer is 15 cosine times 30, 28.9. Okay, the next ones I'm not even going to write out, but I will just give you the answer. Alright, there's all your answers. You should have the tools now to start the extra credit process. If you can apply this to forces at angles, then we can solve for when things aren't linear, like in one direction. We can now solve forces in 2 dimensions.